take this life example regarding radioactive decay. Okay, we have two types of formulas we're going to use today. This one is if you're investing money. Okay, you're investing money. A is the amount of money you're going to have. P is the principal. Principal is the initial investment. R is the interest rate. N is the number of times it's compounded yearly. So it might be compounded once, twice, 4 times, 6 times. But this is when it's continuously compounded. What's the big difference between these two formulas? What's the big difference between those two? What do you notice? What stands out? Yeah, this one's got the 1 plus the R over N. This one's got the E, right? So when stuff is compounded continuously, we use this formula. For example, the growth of bacteria on your phone, we would use that formula. The growth of the money that Dane invested, we use this formula. The population of rabbits, we use this one. They multiply all the time. Right? The amount of money you owe on your credit card, we would use this one. Okay? The growth of a tree, we would use this one. Trees continue to grow all the time. Okay? So, radioactive substance decays in such a way that the amount of mass remaining after T days is given by this function right here, where M of T is measured in kilograms. Sounds really confusing? No big deal. As you can see, we have E because the radioactive substance continues to decay all the time. It doesn't just pause and start again. Pause, start again. So find the initial mass. The initial mass will be at what time? Initial means at time. Yep, beginning. So time equals 0. So all we do is we take 0 and we plug it in for T. So M of 0 is 23 times E to the negative 0.0043 times 0. What is negative 0.0043 times 0? 0. What is E to the 0? 1 times 23? 23. So the initial mass is 23 kilograms. Everybody okay with that? How much of the mass remains after 21 days? Now what do you think I do? Plug in 21. So M of 21 is equal to 23 times E to negative 0.0043 times 21. Good thing I got a calculator for that. A lot of people can't remember where to find E. We would just go second natural log, and it'll take E to an exponent for you. Negative 0.0043 times 21. I get 21.01. Easy enough for everybody to do so far? Now we'll change it. It says, after how many days does it have a mass that is half the initial? A mass that is half the initial. Well, that sounds important. Now, instead of finding the mass, what variable am I solving for? Yeah, the number of days, the time. I want to find the time. Well, if the mass is half the initial, what's half of 23? 11.5. So 11.5 is equal to 23 times E to the negative 0.0043 T. So I use the same equation. I just use 11.5 for the mass, and I'm trying to solve for T. This is like what we solved yesterday. What is our first step to solving this equation? What has to move first, the E or the 23? 23. Divide both sides by 23, we get 1/2. Uh-oh, I got 1/2 is equal to E to the negative 0.0043 T. Looks super complicated, but fortunately yesterday we learned that in order to get rid of E, what do you do to both sides? Natural log. I didn't hear it, but I saw Spencer mouth it. He's like, very good, buddy. Natural log of 1/2, I happen to have memorized that over the course of the past couple hours, which I taught. Comes out to be negative 0.693 is equal to, and here the natural log and E cancels, leaving me with negative 0.0043 T. negative 0.693 divided by negative 0.0043. And I get 161.163. So it's going to take about half a year for it to decay to a point where it's half its initial mass. Okay. So why are logarithms important? They help us solve exponentials. Everybody okay with that? All right. Next example. If $1,500 is invested at an interest rate of 8% a year, compounded semi-annually, find the value of the investment after 5, 10, and 15 years. Okay? So Spencer's going to get an investment. He's got $1,500. He wants to invest it. He's going to say, well, how long should I leave in the bank for? It's a good question. Let's use this formula. The amount after time t is equal to, well, is this compounding every so often, or is it compounding continuously? Every so often. In fact, it's compounding twice a year. So therefore, we have the principal times 1 plus the rate over n raised to the nt power. And you don't have to memorize those formulas. I'll give them to you on the test. So we want to know the amount. What is the principal, the initial investment? 1,500. 1 plus, what is my rate? 8%, 0.08 divided by how many? What is the number of times it's compounded during the course of the year? Twice, raised to the n is 2t. So what you're going to have to do is you're going to have to plug in 5 for t, 10 for t, and 15 for t. Now, I don't know about you guys, but I want to save time here. So instead of plugging that in 3 times, what I'm going to do is go away. What I'm going to do is I'm going to go to y equals, and I'm going to type that in. And I'll just go to my table, and I'll do 5, 10, and 15. That sound like a quicker way to go about this? Great. So we'll go 1,500. 1, let's see, 0.08 divided by 2 is 0.04. And then raised, and I have to put parentheses around this, 2x power. We'll just substitute x for t. And then I go to my table, and from the previous class, you can see I already have 5, 10, and 15 entered. So that means that the amount after 5 years is equal to, and just in case you didn't know, if you go over to your table, you highlight it, you can see that the y sub 1 value, it shows the entire value. So we want to carry it out to the hundredths place. I think hundredths, you guys be fine with hundredths. We go to pennies. Is that all right? Okay. So we got 2,220.37. And then we've got the amount after 10 years is 3,286.68. Oh, wow. Nobody goes to school anymore. They all just roam the hallways. Hope they all have e-hall passes. The amount after 15 years is 4,865.10. How's that? Is that okay? Just, can you guys notice what happens here? Between years 5 and 10, it goes up by what? 1,000. But between years 10 and 15, it goes up 1,600, right? Like, the last 5 years were better than the first 5, right? And so the fact of the matter is I know that my retirement, the last 5 years are really important. I mean, my savings are going to grow a lot more than they did, you know, in some of the years before that. So it's really important to start early. That's the power of that compounding interest. Get rid of problem 3. Let's go to problem 4. Let's go to another investment. This man's going to invest $2,000 in an account that's compounded annually. Annually means how often? Once a year at an interest rate of 5.5%. What is the amount of the investment after 4 years? Now, we're going to solve the second part. How long does it take for the investment to double? We'll do that together. But see if you just come up with the first initial amount. Go ahead, try that. Okay, hopefully you set up the amount after 4 years is equal to 2,000 times 1 plus 0.055 over 1 raised to the 1 times 4 power. What did you come up with? Is everybody okay with that? there any question how we came up with that? I'm trusting Dane. Can somebody else confirm it? Doyle confirms. We got Dane and Doyle. Very good. So how long does it take for the investment to double? How has the problem changed? We're looking for? What variable are we solving for if we're looking for how long does it take till it doubles? Time. We know the amount. If the investment has doubled, what is the new amount? The investment doubled. $4,000. When is the investment equal to 4,000? That's the big question. Looks like a very complicated equation, but fortunately, since we all did work yesterday on this, this is going to be super easy. What do I do to solve? What do I start with? You divide by 2,000. 4,000 divided by 2,000 is 2. I have to get at the t. How do I get to the t? I have to get rid of 1.055. Get rid of 1.055 by log base 1.055. Those are gone. We're left with t is equal to. Go my calculator. Log of 2 divided by log of 1.055. So Logan says, I've got $2,000. I'm going to leave in the bank until it doubles. He's got to wait 13 years. Okay. Do you get 5.5% of the bank right now? You get 0.1%. That's what happened after a recession. So, it's very on the flip side of it, my parents, when they first got their home loan, like a mortgage, my parents had a mortgage of around 13%. Now the mortgages are around 4%. So as these drop, you're going to see the savings amounts drop as well. And that's why you have to look for other ways to invest your money right now. So, all right, two more. Investment of $800 compounded quarterly over 6 years. The initial investment resulted in $1,245.83. What was the interest rate of the investment? Ooh, so now what variable am I looking to solve for? R. So the amount is $1,245.83. So I'll set that equal to the principal. What was the initial investment? 800 times 1 plus, what was the rate? We don't know. We're trying to find it. Divided by, how many times is it compounded each year? So 4 raised to the, anybody know what power I raise this to? 4 times 6, 24. So I got to get at the R. What has to move first? 800, so I take 1,245.83, and I divide that by 800. And I get 1.5572 is equal to, parentheses, 1 plus R over 4 to 24th power. Now it has to move. Now what do I need to get rid of? Very common thought is to take this 24 and dump it in front. That's a great idea, but it only works if there's a logarithm. So for example, you have the logarithm of x to the 24th power. Then you could take that 24 and put it out there. But we don't have a logarithm, so we can't move that right now. you could distribute, except you can't distribute exponents over addition. It would have to be multiplication. It's going to require somebody to see the aha moment. What if instead of 24 is just, what if it was just squared? What would you do to both sides? Square root it. 24th root it. Or 24th root both sides. Yeah, how do we do that on our calculator? We'll take 1.5572 and we'll raise it to the parentheses 1 divided by 24 power. And we get 1.0186. And that's equal to 1 plus r over 4. Now, I've gotten rid of that 24. What do I do to solve? Subtract the 1. After I subtract the 1, times by 4. And you can see we get a grand total of 0.0745. R equals 0.0745, or 7.45%. Not too bad, huh? All right, last example. Population of rabbits modeled by this function right here. Looks crazy. P is measured in thousands, and it's the number of rabbits, and time, or T is the number of years the population was tracked. Find the population after 10 years, and find how many years it takes for the population to reach 8,000. If I want to find the population after 10 years, what would I do? Plug in 10. Yep. So the population after 10 years is equal to 30 divided by 1 plus 5e to the negative 0.3 times 10. That's kind of a weird looking equation, but we can determine it by simply plugging it in. 30 divided by parentheses 1 plus 5 e to the, I'm just going to do negative 3 because negative 0.3 times 10 is negative 3. And I get 24 rabbits. That doesn't seem right. 24 rabbits. 24,000, because it says that we're measuring the population in thousands. So you get 24.020, which is really just 24,020 rabbits. Suppose the question was different. Instead of saying the population after 10 years, what if I said find the initial population? If it said find the initial population, what would you plug in for T? 0. If you plug in 0, you get e to the 0 is 1, times 5 is 5, plus 1 is 6, and 30 divided by 6 is 5. So 5,000 is what we start with. After 10 years, there's 24,000. It's a lot of rabbits. Better get some wolves, right? How many years does it take for the population to reach 8,000? I'm solving for T. What do I plug in for P? 8. It's measured in thousands. So don't plug in 8,000, plug in 8. There's 2 ways to solve this. I gave this problem to you yesterday in your notes or in your assignment. Some of you would put this over 1 and cross multiply. That's fine. I'm going to choose a different method because it's free country and I like to do what I want. I take the reciprocal of both sides. I'm going to get rid of the 30 in the denominator. So I multiply both sides by 30. So 1 over 8 times 30 is 3.75. Now what? Subtract 1. After I subtract 1, divide by 5. I get 0.55 is equal to e to the negative 0.3t. Still got to get at the t. Natural log of both sides, because that will get rid of the base of e. The natural log of 0.55 is negative 0.5978. Divide both sides by negative 0.3, 1.99. That's how many years? About 2 years for the population to reach 8,000. And hopefully that should make sense, because we said after 10 years, it will reach 24,000. So there you go. That is all of your work. You guys did a great job. I told you this would be a fast unit. It was this week. It was 5 lessons. It was 5 worksheets. That's it. What about this test? Is it easy? Is it difficult? It's both. I see people who do great on this test. They're like, that was easy, Mr. Gens. You made us worry for nothing. And then I see people pull 50%. So it's really going to be up to you and whether or not you do your work this weekend and check the answer keys and make sure you get your questions answered. I wish I could tell you everybody's going to do well. I told you last test that we were going to see really high scores. We did. I'm going to tell you this one, you really don't know.